Hello everybody, and well, hello to those who are watching me. And you probably saw the other experiments that I did on the breadboard. It's exactly the same circuit as before. I have it here, this guy, which is having 5 volts through these two alligators here, and this cable that saved the entire project pretty much. This shielded is called a shielded cable, and right now I have a 20 megahertz crystal oscillator there, and the reading from the frequency meter from this device, which is limited to 2 megahertz maximum, so I have to lower down the entire frequency of the reading that of the oscillators that I'm putting here. This device is by far is not perfect, is having a lot of issues. Sometimes are worse, sometimes are not that worse, sometimes are better, but is not a very stable circuit. I am not sure why exactly, but it's I cannot trust it 100%. I can trust it to a point, is what I'm saying. It's a good circuit, although it's a very good circuit. So right now I will put different crystal oscillators, quartz oscillators, how they are called, and this is 24 and this is reading 200, and it's a 1 by 100 division, exactly like the other. So this is 14 megahertz, and let's see, usually this was read extremely well until now. Only on this circuit. All the other circuits on the breadboard, they give me good results. A lower frequency, it's having a margin, a limit, a minimum limit and a maximum limit of reading, but is extremely limited for some reason. I really like how it's looking right now. Everything that you see here is come on, get inside, little shit. No, it doesn't. Now I get it. And this wire is not staying very well here. It's kind of flying away. It's a very prototype. Now it's reading fine. Finally, probably it was a misalignment, missing. All right. Sometimes it's working, sometimes it's not working. Is with especially with the known values. But with unknown values, I don't know. This is 27. This is 27. For some strange reason, 270 megahertz. Yeah, you see, 270. Absolutely incredible. These guys didn't work at all on the breadboard. They gave me 90 kilohertz instead of 270 like they are but here on this board they are at home. And I have another one, again the same 27, yes, the same 27 megahertz, and I remember he was behaving as well good. Not this time, eh? Not this time, no, you don't. Right now you want to fuck me. To fuck my movie. Well, it doesn't. But I got in previous readings, I got a good reading. Yeah, see? 270. Come on. So it's kind of working. This cable saved my ass, literally saved my ass. I had another cable from simple wires. I put the shortest wires possible and inserted in that connector there, and those it give me very random readings. You can do it. No, it shit itself right now. No, doesn't like it. But all these guys, that a lot of them actually, I read it with the similar circuit when it was on the breadboard. But here is the final circuit, and it's kind of working, and is pissing me off, and I really don't know what's the problem really. I mean, it worked for a this is what, this is 24 megahertz. It worked excellent for a while. Yep, 24. So between 20 and 30, probably 30, because the 27 it read it well. But so between these values, 20 and 20 and 30, is kind of good. It's kind of good. This is 25. Let's pray it will work. 20, 25, 200, 250. Excellent. It's catching glimpses of. This is another 14, and this is 32 megahertz. Let's try it with this guy. 32. Probably the contacts are. It doesn't like the contacts. No, it's reading 1 hertz. 1 hertz, really? And no, doesn't like. Over 30, it doesn't like it at all. It needs some tweakings somewhere. I have no fucking idea. I really don't know where to tweak it. Where should I tweak it? I don't know. But it's kind of working. Now it's inserted in the contacts. Probably these contacts are fucked up, really fucked up, and I bet my life it's the contacts. They're not really. Of course, I made everything here. I repurposed everything, and this is 35. I know all this 30 doesn't like them at all. Let's see. You will surprise my ass if you will work. Hoppa! And he wants to surprise my ass. 35, 320, kind of. All these markings that you see here, I read it with this guy when it was on the breadboard, and I write them here because it was a brief moment in time when it worked absolutely incredible. And I used the same circuits, integrated circuits that you see here. I took them out from that breadboard and put them here in this final board that you see here. And it's time to present it right now, to show it more closely, probably, right? And I will close my guy here, and I will film it like this. Hopefully it will. So everything is all the circuits are underneath, and on top of them I put the last circuit, integrated circuit, the last IC here, and pretty much this is it. And all the jungle of wires that you see, especially here on the top, here it's a jungle of wires, and if something will get out from its place, the fuck, I will have to take out this board on the top and get in there and solve the problem. But The idea that it's a good design, kind of good design, but if I have to repair something, no, no way. And let me show you. I hope I can find it very quickly, because I switched to this mode right now because it's more intuitive to see everything. Um, right now is in simulation mode in Proteus, as you can see, Proteus 8. And I have this is the entire circuit schematic. So this is on the breadboard. When I did the last testing, it was working excellent with maximum of 40 megahertz, but I had another dude who worked for him this entire circuit that I have here. It worked for him equal to 40 and probably even more than 40 megahertz, but not for me. For me, it didn't read at all the 40 megahertz crystals that I had at all, but it got up to 40, like 30 something, 35, 37, I don't remember exactly, but 38 megahertz. But it read until that maximum of 40, but not equal. That's my point. But it did work with another guy who was having a better oscilloscope, better knowledge about the thing. He actually, this is his circuit that he guided me with it. On the bottom it says this output stays high all the time because it needs another flip-flop to toggle visible. This is the output that I'm mentioning there. So it says actually here 1/100 output. So if I'm putting right now is a 20 megahertz crystal right now there, and the output is 200 kilohertz. It's exactly as in my real circuit. And here are the actual circuits. I will do it like this because this is one IC which is split in four. It's having four NAND gates inside. 74L0 LS00, and it's fucked up. Pizda mătii, este fătă în pizda mătii. What? 74HCT73. This is a single chip here. 74LS93. This is one single chip by itself, and this is another one single chip. And the fifth chip that was on the top are these guys. This 4 and 5 is from the fifth chip, what I see on the top. And this is the actual output. That this is a positive signal that I get here, and for one probe of the frequency counter, and the other probe I put it to the ground to the minus. So this is it about the original schematic that I used, and it worked perfectly on the breadboard up to 40 megahertz like I'm mentioning here, but with the final circuit it worked up to 30 and between 20 and 30, unfortunately. So yes, this is it. Thank you very much for watching, and I hope you can I can see you later. Bye bye.